x. So change the y over change the x. And that will give us the slope. Okay, it's the same as m. Okay, so in the same way, if you want to find this, let's say at every point you can find slope there. At every point you can find slope there. So the slope at a point, slope at a point can be denoted. You can show it by this dy dx. Okay, and that is this one. When we are doing this, we are talking about what we call differentiation. Okay, so that's this concept here. So slope we can take about differentiation, adding we can take about. So adding we can think about integration, slope or gradient. We can think about differentiation. Okay, so this is how we're going to use it. So in future we'll talk about how we can use integration and differentiation. Right? Okay, so this. Now you realize that like we said, if you have y is equal to 2x. If we add something small to y, let's say y plus something small, we can make it this. Then x, once we have added something small to y, x is also going to change. So x is also going to have something small added to it. Okay? So when we are doing something like this, something small added, we call that calculus. Okay? We can use the differentiation or integration method. So here, if we work it such that from here, if we work it such that we have change in y, small change in y, small change in x, we are talking about what we call differentiation. Okay. Now, if we sum them, if we try to get the summation, okay, y, let's say y equal to 2 divided x plus your change in x over this. If we get the summation over a period, then that becomes, so if we are looking at this is summation, we are summing the things we are doing. This is a symbol for summation, then we are talking about integration. Okay, so this is just the basis. Okay, but just focus on this diagram, how they can get the area. Focus on this, how they can get the slope. Just talk about these two for them, and then let them play around with. We have the play tools for this one too. Then let them sketch. Okay, and then it will build them up for calculus. Let's talk about probability. So when you talk about probability, let them understand is, let's say we have this. So let's assume these are balls, 5 balls in the basket. Okay, these are the red ones, these are the white ones. Okay, I can ask you how many balls are there. You say 5. How many are red? So red is equal to 3. How many are white? 2. So I can ask you, what is the fraction of white considering the whole or the total number of balls? So fraction means part. So how many parts of white are in the total? So you see that here we have 2 whites in 5, 2 whites in what? 5 balls. Okay. So the fraction of whites there is equal to 2 over 5. What will the fraction of red there? Red we got 3. Red is 3. Okay, we have 3. 1, 2, 3. So it will be 3 over the total. 3 over the total, which is 5. So the amount, your amount over the total is what we call fraction. And this fraction we can call probability. Okay, we can call it probability. So we can let them have a basket. Okay. Then you let them close their eyes, pick one. The probability. So probability means the chance. So this is the chance. The chance that you pick something. Okay. Chance that you pick something. Okay. So the chance that you pick something, because it's in fractions, total is always equal to 1. Okay. That's what it gets. Sometimes the probability will not be in fractions, it will be in order arrangement. We call that, we look at it as permutation and combination. Permutation and then combinations. Okay. So let's say I've let the word. Okay. I can make it like this. I can make it like that. Okay, I can make it like that. Okay, so I'm arranging them. When you're arranging them, we call that arranging. Arranging is permutation. Okay, when the order does not matter, order does not matter, we call that combination. Okay, so here when we say this one is different from this is different from this is different from this, then we are talking about permutation. But if we say this, because the same words are here, the same words are here, the same, if we say they are the same, they are the same, they are the same, then we are talking about combination. Okay? So just note the two. Sometimes the number of ways we can arrange over the total number of ways of arranging everything. So let's say I have elements here, these are elements. Okay? Number of ways of arranging this, let's say white, over total number of ways of arranging red. Let's say red. So this is white, this red, this red. Ways of arranging. So arranging white over ways total ways of arranging all. Also be equal to probability. You can look at it as also probability. Okay? So we don't only use fractions, we can use permutations and combinations also to represent probability. Okay? So we can let them play around. Okay? And then use words, okay? Or use balls, okay? Then you can talk about the die or the dice, the little die. You can talk about the coin, let them play with them, okay? And you get the alright. Remember, total probability is 1 for that action. For one action, total probability is 1. If you add all the points together, you get 1. Okay. Sometimes one action may depend on the other. Let's say you have two groups, they intersect, they share. If they share, you must remember that you must have the probability of 1. Let's say total probability. The total is going to be what? A, probability of A, probability of B, minus probability of what? A intersection B. So there's a minus if they intersect. If they don't intersect, then it is A plus B. That will give the total. Okay? That one is there. That concept you can look at it. So this is just a brief thing. We'll talk about it when they get to the upper class. Right? Now the last part I'm talking about is statistics. Okay? So let's say you have people. Okay, let's say this one's height is 6, this one's height is 10, this one's height is 5, this one's height is 4. So they are in a class. If I ask you what is their average height, so when you say average, it means you want to find something that will be between, that will be common for all of them. So common in that sense, common for all of them, or in between for all of them, in between for all of them, that will be average. So that to get the average, what you can do is we can say maybe the height is between 6 and 10, is between 5 and 10, is between 4 and 10. And so what you can do is we can add all of them. So add or and divide by the number of numbers there. Number. Okay, and that we call that average. It's also called mean. Okay? Now if the number, let's say 2, 4, 5, 7 is small, so the number with the higher number of numbers, we call that is the mode. Okay. Now we can also arrange numbers. Okay. So we have 5 numbers there. Which one is in the middle? 3. We call that the median. Okay. So you can let them play around things like this. As they are going up, then we'll be bringing in. So we know mode, we know median, we know average. This is good for statistics. Then you can look at how to vary them in the various aspects. Okay. Right, so I think at this point you can look at the diagrams. Have the pie charts, you let them go in degrees. Okay, pie chart, so you have distribution. Let's say this is red, this is green column, okay, and this is yellow. Okay, so that's the pie chart. You can let them do the pie charts. You can let them do the bar chart. Okay. So this is representing boys, this is representing girls in the class, okay? Can I let them do the histogram? Let's say these are the height of people, okay? So let's say from 5 to 10, 10 to 15, 15 to 20. So this is the histogram. histogram. So this is a continuous kind of thing. They are not continuous, they are disjointed. Okay, they are not continuous. Okay, so these ones are there to show. They can have the frequency table. You can have frequency. So frequency is here. Now that's number of times something is happening. And frequency. Then you have the mass here. Okay, you can do it. Then you can have maybe the chart like that. So if you have something like this one is almost symmetrical. Symmetrical means this half is the same as this, so symmetrical. Sometimes it will not be symmetrical, it will be like this. So say it is skewed. It can be skewed to the left or it can be skewed to the right. So this is skewed to the right. It means the tail end, the more part is on the right. It can be skewed to the left. That is this. Okay? So these things can also come. Just draw the pictures, let them play with the sketches, okay? Not necessarily knowing, but playing with the sketches. So as they grow, we'll be getting them to understand what we'll be talking about in the future. So this is a good picture for our probability kind of thing. Right. So if you want to standardize, so sometimes you want to find a difference. The difference between numbers and then the mean. So difference, we are talking about deviation. The average deviation we call standard deviation, okay? If we are comparing between two different populations, we call that standard error. Okay? So standard deviation for different things, two different things is standard error. For the same thing is standard deviation. And then just a difference is deviation. Okay? Now, of course, we know that the difference is D. When you square difference and find the mean of difference, we call that variance. Okay? We call that variance. Okay? And then the square root of variance is equal to standard deviation. Okay, so these are the things that and then so the formulas, get them, and the concept will come in. So we're building them up for the future. Right. So at this point, I think we have exhausted all the topics. Let me see which one we have left out so that I bring them in. The last bit I'll add is this one, which is very important to end the discussion. Relativity, relative, resultant, and then change. These three, I want to bring them. Okay, this will end the final. When you say, let's say, A is going, B is coming like that. You can say the velocity of what? A relative to B. So velocity of A relative to B. So relative to B means B is the starting point, is a point, is a fixed point, is the reference point. Okay? So you let B as it is. So what you do is you just need to have your A there, and then you subtract your B by depending on whatever it is you are subtracting. So you hold your B, the one that you want to find constant, and then subtract this one from it. Okay, when you are subtracting, you must consider the sign for this one. Resultant means you add them. Okay, so this one is this. Let's say this force is going this way, this force is going that way. If this one is pulling this, it will come this way. This is the resultant. Change is the same body, there is one body. So I'm going this way and then I move that way. So I was moving this way, that way. So going this way and going that way, what will be my change? So my change will be the final minus the initial. That will be change. Final minus initial is change. Okay? So at this point, we'll end it here.